Hello, my name is Richard Trainham. I'm starting a YouTube video to do math challenges, puzzles for fun. Today I'm taking a look at puzzle from the 2020 Putnam exam. This is question B2. I'm going to be paraphrasing the problem, not reading it off exactly. And I picked this puzzle, or this problem, sort of like a puzzle, because I really like math problems that involve games. They tend to have some very interesting strategies that aren't purely mathematical, like an algebra problem. Anyway, so in this problem we have k pegs and n holes, where k is strictly less than n, and of course k and n have to be integers. So k is at least 1 and smaller than n. K pegs, n holes. Okay, so here's an example. If k is 2 and n is 5, what we're talking about is we have 5 holes and 2 pegs. Now the pegs start off in the leftmost positions. That's these 2 dots right here are the starting positions for the pegs. The goal of the game is to try to move all of the pegs as rightmost as possible, and then if it is your turn to move and they're already in the right spots, you lose. Or another way of saying it is that the first person to move them into the far right spots at the end of their turn, they win. Okay, the game is going to be played with 2 players, player A, Alice, and player B, Bob. Alice is going to go first, and then Bob goes second, and so on. So let's just take a look at this and see, can Alice win? Will Bob win? What's going to happen? Okay, Alice is going to want to move. Oh, and I forgot to explain. Each move consists of taking one of the pegs and moving it to a new hole that is empty to the right of its starting location. So the pegs will be continuously moving to the right until eventually they're all as far right as possible. I think I'm just going to start the video over again. Okay. Hello, my name is Richard. I am starting a YouTube channel to do math puzzles. Usually they're going to be taken from various math exams, although they may be some puzzles that I find in other locations. I'll usually try to cite the source of where I found the puzzle so that you can take a look too. Anyway, today we're taking a look at the 2020 Putnam exam problem B2. Now this problem is a problem involving a game between 2 players. The first player to move is player A, and the second player to move is player B. We'll call them Alice and Bob. Okay. The game is going to consist of k pegs and n holes, where k has to be at least 1. There's at least 1 peg. N is the number of holes, which is going to be less than the number of pegs. Here's an example: 2 pegs, 5 holes. Okay. The starting position is that all of the pegs must start at the very left. Okay. And when it's a player's turn to move, they have to move one of the pegs to an empty hole that is further to the right. Okay, so for example, Alice is going first. She might move this peg into this hole as her first move. And then it would be Bob's turn, and he would move one of the pegs, into an empty right slot. Now, eventually, when they're all to the farthest to the right, the next person doesn't have a move, and they will lose. Another way of saying it is, if on your turn, after you've done your move, they're all to the right, you win. Okay, both of those would be equivalent. Okay, I really like these math problems that end up being puzzles because I like the way that you have to solve them. It's not just purely mathematical. I love that you first have to do a little bit of exploration, try to figure out what's going on, and then eventually develop a strategy. And there are some strategies that work for game problems, but the first part is going to be just figuring out the game. Anyway, so let's take a look at this example: 2 holes and 2 pegs and 5 holes. Okay, let's see, does Alice have a winning strategy, and what would it be? Well, if she moves one of these into one of the far right holes, Bob's just going to do the move into the other two holes, and Bob will win. Okay, so Alice can't do that. She doesn't want to move either of these into one of these two holes. So she must want to move one of these into this hole. Okay, well, if Alice does this, then Bob will do this. And then Alice is forced to move into one of the last two, and Bob will do the other, and Bob will win. So that's bad for Alice. Okay, the move that Alice wants to take is to move this into this hole. Then Bob will have to move one of these two into one of these holes. It doesn't matter which one. And then Alice will move the last one here. So for k equals 2 and n equals 5, Alice has a strategy that no matter what Bob does, Alice will eventually win. Okay, so the question is, for what values of k and n does player A, Alice, have a winning strategy, and what is it? Okay, so we've explored 2 and 5, and you could explore other cases, but there's an infinite number of cases, so we're eventually going to have to develop a strategy. But here's one special case that I want to focus on because it's going to be the key behind some of the other strategies. And this is going to be when we have 2 pegs and 4 holes. Oh, and after looking at some other cases, you may start to see that Alice is winning a whole bunch. But this is like the first case with the smallest value of n for which Bob can win, okay? And actually, it's a forced win for Bob. There's no way that either player can do any moves that doesn't let Bob win. That's because on Alice's first turn, she's either going to move this to one of these two. It doesn't matter which one, like that. And then Bob will move into the last one. Okay, so I said sort of Bob is forced to win. They have to play a little bit intelligently, and then Bob will win. If Alice moves this one into one of the last 2 holes, we get the exact same situation where Bob eventually wins. Okay, so k equals 2, n equals 4 is a case where Bob wins. Okay, if you explore a little bit more, you'll find that when n is 6, there's 2 more cases where Bob will win. This is the first one, where k is 2 and n is 6. Actually, let's explore k is 4, n is 6. Okay. So Alice, if she moves, let's see, well, if she moves either of these back 2, then Bob will just move the other and Bob will win. So Alice can't move either of these back 2. So let's say she moves this one there. Okay. Then what Bob can do is he can move this one here, like so. And it didn't matter whether Alice moves the 3rd one and then Bob moves the 4th, or Alice moves the 4th and Bob moves the 3rd. Either way, this is going to be the configuration. Then these pieces can't move any further to the right. So this situation is sort of like you have k equals 2 and n equals 4, which we already know is a Bob win. Yeah, there's just 2 more moves, Alice, Bob wins. Another case when Bob wins is when n is 6 and k is 2. Okay. Let's say that Alice does this, then Bob can do that. And then once again, if you ignore these 2, this is the same 2 and 4 case. 2 pegs, 4 holes, and Bob eventually wins. You know, if we continue this, Alice does the next move, Bob does the next, and Bob wins. Okay, so we have seen that if K is 2 and N is 4, this is a Bob win. When K is 2 and N is 6, that's a Bob win. And when K is 4 and N is 6, all of these are Bob wins. So you might begin to suspect that Bob wins or has a winning strategy when K and N are both even, okay? And if you investigate a lot of the other cases, you'll eventually see that there are strategies where Alice can win, although you're trying to go pretty far into like larger values of N, it just becomes really hard to figure out the formula until you sort of figure the exact strategy for both players. So let's now prove that Bob wins, when K is even and N is even, and I will also prove that Alice wins in all other cases. Okay, so first let's prove that Bob wins if K is even and N is even, okay? Instead of circles, I'm just going to use lines. 1, 2, 3, 4, 5, 6, 7, 8 lines, okay? And maybe we have 4 pegs, okay? And the total number of lines is even, total number of pegs is even, okay? What you're going to do is you want to think of groups of 2, okay? Each group of 2 pegs, as you go from left to right, is either fully occupied with pegs or fully empty, no pegs, okay? And here's going to be Bob's strategy. Whenever Alice takes a move, she's going to have to move one of a pair to a new location. Then Bob moves the other member of the pair into the same group of 2 that Alice moved hers into. Like that. Okay? And Bob's just going to repeat this over and over again. Whenever Alice does a move, taking one piece out of each of these groupings of 2s and moves it into a new grouping, that's going to create a situation where Bob can then move the other member of that pair into the same grouping that Alice moved hers into, reestablishing this pattern that every grouping is either always filled or always emptied, okay? And eventually the winning state is this state. And because of the way Bob is moving, at the end of Bob's turns, that's the only time that each of these groupings is either completely full or completely empty. So that with this strategy, at the end of Bob's moves, it'll eventually be this state. At the end of every Alice's move, there's going to be 2 groups that have, 1 peg each in 2 different groupings. See, and that's not a winning state at the end of her turn. Okay, so that's the proof that Bob wins when K is even and N is also even. Okay, let's call that case 1. So case 1, K even, N even, Bob wins. Case 2. Now let's think about what if K is even, but N is odd. Okay, what's going to be, I think we can make Alice win. How do we do that? Okay, let's say that we have 5 slots and K must be even, so we'll do 2 pegs. Okay, and the secret is going to be to try to create a situation where after Alice's turn, she will hand off a problem to Bob, or a state of the game that is essentially case 1, in which the person going first in that, case 1 loses. See, B is the second player, B wins if the state of the game is k even, n even. Okay, so what is Alice going to do to create this situation? Well, in this case, she can move the far left peg into the first empty hole, okay? Then, because this is now empty, it's like we're getting rid of one peg because we can't move pieces back. So we've created a situation where the number of pegs is even and the number of holes is also even. And so that's going to make the next player lose. The next player is Bob. Bob loses, so Alice wins. So the strategy in this case is Alice moves far left peg into the first, let's say the leftmost open hole. Leftmost open hole. And then that will allow Alice to win. Okay, case 3. This will be when k is odd and n is even. Okay, 1, 2, 3, 4, 5, 6. And let's say that there's 3 pegs and 6 holes. Okay, once again, Alice wants to do a move that will essentially turn the game into even, and then Alice will eventually win. She can do that this time by moving the far left piece into the far right open hole. Okay, because this piece, since it can no longer move to the right, is essentially out of the game. And since this hole is open, you can ignore that too. So you can sort of ignore this, ignore that, and then you've gotten rid of 2 slots essentially, keeping n even, and you've gotten rid of 1 piece because it can't move anymore. So k is now even also. And you create an even number of slots and even number of pegs and number of holes. Okay, so Alice is going to win by doing the move. Alice moves far left peg into the far right hole, and Alice will win. Finally, last case, case 4. K is odd, and n is also odd. 2, 3, 4, 5, 6, 7, and let's say k is 3. Okay, I believe in this case we want to move the rightmost peg into the rightmost open hole. This hole will get filled and the piece can't move, and the slot and the hole is now filled, so we can ignore it. And now we have an even number of pegs and an even number of holes. And once again, Bob will lose, Alice will win. So in this case, Alice is going to move her far right piece into the far right hole. Alice moves far right peg into the far right hole. And Alice wins. All right, so there is the proof that Alice wins or has a winning strategy whenever K or N or both are odd. And Bob can only win if K and N are both even. So that's the problem as stated in the Putnam exam. But let me give you a bonus problem related to this. See if you can answer it. Okay. What if we randomly chose a game where we have, K pegs, N holes, where N is less than or equal to 100. Oops, that's a little bit too low on my board. Let's write it up here. Okay, so if you choose a game at random with K pegs, N holes, where N is less than or equal to 100, and you choose one of those possible games at random, what percent of the time will Alice be able to win? And the answer is not 30 or not 3/4, 75%. It's a little bit more complicated. So I think this is a interesting extra problem that you might want to try. Anyway, thank you for watching this video and have a good day.